In this section, we will be introduced to derivatives of exponentials. So first off, the derivative with respect to x of e to the x, so ddx e to the x, just equals to e to the x. Simple as it gets. But if we have ddx of any other term besides x, so it's any expression other than x, so if you have ddx of e to the u, then it equals to e to the u times u prime. You have to use a chain rule. So if this exponent is not equal to x, we always have to take the derivative of that expression, of that exponent, and multiply it by e to the u. Okay, so for example, we're given f of r equals to 4e to the r minus 1. First off, I'm going to write this as u equals to r minus 1, so we can apply that rule. And I'm going to rewrite this as f of r equals to 4e to the u. By this formula, f prime of r equals to 4. That's the constant we just keep on the side. The derivative of e to the u is equal to e to the u times u prime. So it's going to be times e to the u times u prime. Now we know what u is. U is r minus 1. U prime just equals to 1. So now if I take the u and I substitute it back with the r minus 1, this equals to e to the r minus 1 times 1, which is just e to the r minus 1. So this is our answer. Another way to think about that is we have 4e to the r minus 1. We know that when we take the derivative, the e to the r minus 1, this stays the same. And we take the derivative of r minus 1, which is 1, which we don't have to write, so that's our answer. Okay, let's take another example. But before I do this, I'm going to substitute the exponent 3t with u. So I have 3t to the 4th minus 2t plus 7e to the u. So I'm going to use a u substitution. So u is equal to 3t and u prime is equal to 3. Now let's differentiate this. So f prime of t, 4 times 3 is 12. We get 12t to the 3rd power. The derivative of negative 2t is going to be negative 2. And then we have our 7 is our constant. The derivative of e to the u is going to be e to the u times u prime. Okay, now let's substitute back in. So our derivative f prime of t equals to 12t to the 3rd power minus 2 plus 7. U is 3t, so it's going to be 7e to the 3t. And we're going to multiply that by u prime, which is 3. So if you don't want to use a u substitution, that's fine. Just remember to multiply by the derivative of the exponent, which is in this case 3. If we simplify this a little bit, 7 times 3 is 21. So f prime of t is equal to 12t to the 3rd minus 2 plus 21e to the 3t. Next example, we got 7e to the x plus x to the e. So one quick thing to remember, e to the x and x to the e are completely different. Okay, here's why. Here the exponent x is a variable, and we're differentiating that with respect to x. So when we have e to the x, the derivative of e to the x is just e to the x. However, when we have x to the e, remember, e is just a number. So it's kind of like saying this is x squared or x cubed or whatever, but e is a number like 2 and 3 are. So we have to treat e as a number. And so this rule doesn't apply because we don't have e to the x, we have x to the e, and our exponent is a number, not a variable. So these are not the same thing. Now let's take the derivative, f prime of x. So the derivative of 7e to the x is just 7e to the x. And the derivative of x to the e comes to the front, so we have e times x to the e minus 1 power. Okay, and that's it. The derivative of e to the x is e to the x, so we have 7 times e to the x. The derivative of x to the e comes to the front, and we subtract 1 from e, so it's going to be e times x raised to the e minus 1 power. Okay, next example, we got f of x equals to 4e to the x plus 2 plus e to the 4th. Now, once again, remember, e is a number. So e to the fourth, it's also going to be a number. Like, for example, if I said 2 to the fourth, that's not a variable that's equal to a number. In this case, 2 to the fourth is 16. Similarly, e to the fourth is a number. It's a constant. So remember that. These are both constants. So if I take, well, first off, because my exponent is not an x, anytime it's not an x, you might want to use u substitution. So I'm going to rewrite this as f of x equals to 4e to the u plus e to the fourth. So where my u value is equal to x plus 2, and my u prime is the derivative of that, which is just equal to 1. So f of x, by the derivative rule f prime of x, the derivative of e to the u is just e to the u times u prime. So I have 4 e to the u times u prime. And the derivative of a constant is 0. So this has just a derivative of 0. So we're not going to write that. If I plug the u back in, then I'm going to say that f prime of x is equal to 4 e to the u, which is x plus 2, times u prime, which is 1, and I don't have to write the 1. So that's just my derivative. And once again, e to the fourth is a constant, and the derivative of a constant is going to equal to 0. So we don't write that. Now, f prime, remember, f prime, this represents the slope. The derivative is always the slope. So it says find f prime of 0, which means find the slope at the point x equal to 0 for this function. So f prime of 0, this equals to 4 e to the 0 plus 2. 0 plus 2 is 2, so this equals to 4 e to the second power. Okay. All right, next example. We are going to say that let f of x equals to 4x plus 15 minus 7 e to the x, and we want to find the equation of the tangent line. So equation of a tangent line is always going to be like this: y equals to mx plus b, which means we need the slope. And slope, that's equal to the first derivative, f prime of x. Okay, so there's some things to keep in mind. So we have our f of x is 4x plus 15 minus 7e to the x. And since I want the slope, I want to look for f prime of x. F prime of x is the slope at any given point. The derivative of 4x is going to be 4. The derivative of 15 is going to be 0, so I'm not going to write that. 7 is a constant, and the derivative of e to the x is just going to be e to the x. So that's my f prime of x. Now, before I could get the equation of the tangent line, I have to know what is the slope at the point 0, 8. And for the slope, we just plug in our x value, which is 0. So f prime of 0, which is the slope at x equal to 0, is going to be 4 minus 7 e to the 0 power. Now, if you put this in a calculator, e to the 0 power, or really anything to the 0 power, is equal to 1. So we're going to say f prime of 0 equals to 4 minus 7 times 1, which is 7, and that's negative 3. So our slope m is equal to negative 3. Now in this equation, I replace y with 8 because I'm given that. I replace the m with negative 3. I replace the x with 0, and I have b. So negative 3 times 0 is 0. 0 plus b is b, so I get b is equal to 8. Which means my equation is this. Y equals to my slope m, which is negative 3, times x, plus my y-intercept, which turned out to be 8. Okay, next example. Find the derivative of x to the 5th times e to the 6x. Now this is a multiplication problem, so therefore we would use the product rule. We would say this is a and this is b. And the derivative is equal to a prime b plus b prime a according to the product rule. Okay, so let's find the derivative. F prime of x. So a prime, we take the derivative of x to the fifth, that's going to be 5x to the fourth times b, which is e to the 6x. That's my a prime b. Now b prime, we take the derivative of e to the 6x, so that's going to be just e to the 6x, but we have to multiply by the derivative of 6x, which is going to be 6. So remember, it's e to the u. The derivative of that is going to be e to the u times u prime. So u is 6x, so we have e to the 6x times u prime, which is going to be 6. So that's our b prime, e to the 6x times 6. We still have to multiply by a, which is x to the fifth. So if you simplify this a little bit, then we get 5x to the fourth, e to the 6x, plus the 6 we can move to the front, 6x to the fifth, e to the 6x. Okay, next example, we have 7x plus 12e to the x to the fifth power. Find dy dx. So dy dx, we take the 5, bring it to the front. So we have 5 times 7x plus 12e to the x raised to the fourth power. But remember, we have to use a chain rule here. If we take a derivative and our parentheses contains x, then we have to take the chain rule. So the 5 comes to the front, becomes a 4. So it's 5 times 7x plus 12e to the x to the fourth power. But we have to multiply this by the derivative of 7x plus 12e to the x. Okay, we always multiply by the derivative of the parentheses. So let's simplify this. We got 5 times 7x plus 12e to the x raised to the fourth power. The derivative of 7x is going to be 7. The derivative of 12e to the x, that's just going to be 12e to the x, because the derivative of e to the x is e to the x. We can simplify this a little bit. We can bring this to the front. So this equals to 5 times 7 plus 12e to the x times 7x plus 12e to the x, all raised to the fourth power. Okay, and then last example, use implicit differentiation to determine dy dx. So when we do implicit differentiation, we take ddx of each term. So we have ddx of x to the fifth plus ddx of y to the second, and that equals to ddx of e to the y. So ddx of x to the fifth, the 5 comes to the front, this becomes 5x to the fourth, ddx of y squared, and then remember, whatever variable you're taking the derivative of, you put that on the numerator, it just crosses out. ddx of y squared, you take the 2, bring it to the front, that gives you a 2y. Since we're differentiating the variable y, put that on top, so we're left with a dy dx. And that equals to ddx of e to the y. So derivative of e to the y is just going to be e to the y, but we have to multiply it by dy dx because we're differentiating with respect to x, and the variable here is y, so we're going to be left with the dy dx. Now our objective is to solve for dy dx. So let's take all the dy dx's, put them on the same side. So we move this to the right. Okay, so here's what we get. We're going to get 5x to the fourth on the left, and on the right, we have e to the y dy dx minus 2y dy dx. And then you factor out the dy dx. So we get 5x to the fourth equals to dy dx times e to the y minus 2y. And then lastly, to get the dy dx by itself, we divide both sides by e to the y minus 2y. So our dy dx equals to this expression, 5x to the fourth divided by e to the y minus 2y.